Good evening all. This is Satish Kumar, Assistant Professor of EC Department. Now let us see the another video lecture series on block diagram representation in linear time invariant continuous time systems. First, what is mean by block diagram? A block diagram is the interconnection of subsystem representing certain basic mathematical operation in such a way that the overall diagram obeys the system mathematical model. There are four different types of system realization of continuous time invariant system: direct form 1 realization, direct form 2 realization, cascade form realization, and parallel form realization. First, what is meant by integrator? An integrator is an element used to integrate the input signal. The transfer function of an ideal integrator is given by when x of s is giving to s inverse, we can produce output as y of s. H of s is equal to 1 by s, which is equal to s inverse. Adder. An adder is an element used to perform addition and subtraction of signals. Pictorially, it is represented by a small circle that has at least two input terminals and one output terminal. The output variable is the algebraic sum of all the input variables x1 of n, x1 of s, x2 of s, x3 of s added, which can produce the output as x1 of s plus x2 of s plus x3 of s. Next one, multiplier. The multiplier is an element used to multiply the signal by the constant. The gain or can be positive or negative. X of s can be multiplied with k, which is equal to k into x of s. System transfer function is given by h of s is equal to y of s divided by x of s. Ratio of the output to the input. Transfer function can be realized using integrators and differentiators. Differentiators are not used in realizing practical systems. The reason is that it can amplify the high frequency noise. The integrator suppress the high frequency noise. Hence, only integrators are used for realization of systems. And the transfer function of an ideal integrator is given by h of s is equal to 1 by s. Now we can see the direct form 1 realization. H of s is equal to s square plus 3s plus 2 divided by s square plus 2s plus 2. We can take s square as common. 1 plus 3 by s plus 2 by s square. 1 plus 2 by s plus 2 by s square. Therefore, h of s is equal to y of s by x of s. Therefore, y of s is equal to x of s. Y of s can be multiplied with 1 plus 2 by s plus 2 by s square. X of s multiplied with 1 by 3 by s plus 2 by s square. We can take y of s and x of s, which is equal to x of s is equal to output is nothing but w of s. Therefore, x of s plus 3 by s into x of s plus 2 by x into 2 by s square into x of s, which is equal to w of s. Therefore, w of s is equal to y of s plus 2 by s into y of s plus 2 by s square into y of s. Now we can take y of s as common. We can take which is equal to y of s is equal to w of s minus of 2 by s into y of s minus 2 by s square into y of s. Now we can see the direct form 1 realization. X of s multiplied with 1 that can be added with 3 by s into x of s, again added with 2 by s square into x of s, which is equal to x of s output w of s, y of s input w of s. Therefore, y of s plus, which is equal to w of s plus 1 by s into minus 2 by s into y of s minus 2 by s square into y of s. This is the direct form 1 realization. Next, we can see the direct form 2 realization. H of s is equal to s square plus 4s plus 2 divided by s square plus 5s plus 2. Y of s divided by x of s can be written as y of s divided by w of s into w of s divided by x of s. Therefore, y of s divided by w of s is equal to s square plus 4s plus 2. Therefore, y of s is equal to s square into w of s plus 4s into w of s plus 2 into w of s. Y of s divided by x of s is equal to 1 divided by s square plus 5 by s plus 2. Therefore, x of s is equal to s square into w of s plus 5s into w of s plus 2 into w of s. Therefore, s square into w of s is equal to x of s minus 5s into w of s minus 2 into w of s. Now we can see the realization. X of n added with 1. We can produce the output as s square into w of s. Therefore, again added with 1 by s. Therefore, minus 5 by s into w of s plus minus 2 by s square into w of s, which is equal to output as y s square into y of s. Therefore, output function y of s is equal to which is equal to x of y or w of s plus y of s plus 4 by s into w of s plus 2 by s square into w of s. This is the direct form 2 realization. Next one, cascade form. S into s plus 2 divided by s plus 1 into s plus 3 into s plus 4. h1 of s, y1 of s divided by x1 of s is equal to s divided by s plus 1. h2 of s is equal to y2 of s divided by x2 of s is equal to s plus 2 divided by s plus 3. h3 of s is equal to y3 of s divided by x3 of s, which is equal to 1 by s plus 4. Therefore, x of s added with 1, which is equal to y of s w 1 by s into minus 1 by s into x of s. Again added with y1 of s output. Next, another function which can 1 into x2 of s minus 3 by s into x2 of s. y2 of s, which is equal to 1 into y of s 2 by s into y of s, which can produce the output as y2 of s. Again, third one, cascade form, added with which is equal to 1 divided by s plus 4, which is equal to 1 divided by which is equal to minus 4 into minus 4 by s into w of s, which can produce the output as y3 of s. This is the cascade form realization. Next one, parallel form realization. H of s is equal to s into s plus 2 divided by s plus 1 into s plus 3 into s plus 4. Now we can apply the partial fraction method. A divided by s plus 1 plus b divided by s plus 3 plus c divided by s plus 4. S is equal to minus 1, a is equal to minus 1 by 6. S is equal to minus 3, b is equal to minus 3 by 2. S is equal to minus 4, c is equal to 8 by 3. Therefore, h of s is equal to minus 1 by 6 divided by s plus 1, minus 3 by 2 divided by s plus 3, a plus 8 by 3 divided by s plus 4. h1 of s, h2 of s, h3 of s. Now we can see the parallel form realization. X of s added with 1, which can produce the output of y of s multiplied with minus 1. The constant value is minus 1 by 6. We can get y1 of s. x2 of s added with 1 by s into minus 3 by s into w of s, which is equal to constant value minus 3 by 2. Again, x3 of s added with 1 minus 4 by s into w of s, which is equal to constant value 8 by 3. Now y1 of s added with y2 of s, y2 of s added with y3 of s, which can produce the output as y of s. This is the parallel form realization. Now we can see the assessment. The system transfer function is given by h of s is equal to y of s divided by x of s. Block diagram representation is the interconnection of subsystem representing certain basic mathematical models. The output variable is the algebraic sum of all the input variables. What does mean by impulse response? When the unit impulse is applied to your linear time invariant system, which produce the output as impulse response h of t. List the methods to realize block diagram representation: direct form 1, direct form 2, cascade form, and parallel form. What does mean by multiplier in block diagram representation? To multiply the signals. When x of s added multiplied with k, which can produce output as y of s is equal to k into x of s. The transfer function of an ideal integrator is given by h of s is equal to 1 by s or s inverse. In direct form 2, the system function is represented by h of s is equal to y of s divided by w of s into w of s divided by x of s. Thank you.